In this video, we're going to learn how to write basic C programs, and we're going to talk about how programs are executed. C is a programming language that has been around for a while, and the reason that we've decided to teach C in this course is because C as a language gives the programmer more control over what the computer is doing. We believe that in the context of learning fundamentals, it's more beneficial for the student to be able to get a better idea of what the computer is actually doing when they're writing programs. So that's why we're deciding to teach C for this course. So we're going to work through the first module for the course together in this video. Before we get started with that, we're just going to open up a new terminal session and we're going to check where we are. We're going to download a program that we're going to use moving forward to install the modules for every topic. So inside of your terminal, we're going to navigate to an appropriate directory where we want to store our modules. So we recommend just either having your module directory inside your desktop directory, which is just here. So right now we're in this Wesley Fu directory. So if we list, we can see all our directories here. So we recommend changing into your desktop directory and keeping your module directory in here, or we could go into your documents directory and have your module in here. So basically go into the directory where you want to keep all your modules, and let's make a new directory. We'll call it, you can call it whatever you want, but I'm just going to call it programming course. So mkdir programming course, enter. You can see that we have our new directory right here. So let's change into programming course. Now I'm going to use the tab to autocomplete and then enter. And then we'll clear the screen. So if we list, we can see that there is nothing in the programming course at the moment. Now we're going to, inside the directory that you just made for your modules, you're going to run this command. It's a bit of a long command, so you can get the command from the website in your modules. So for the first topic, executing programs, if you go down to setup, I think you can just copy and paste this command right here in the heading setup clang and get module.sh. So copy and paste this heading, this command here. Don't copy the $sign. The $sign just represents the command that comes after this. So you can see the $sign there. Yeah, so just copy and paste that and enter. Now what this command does is it goes and downloads a program from the internet called getmodule.sh. This is the program you're going to use to download all the other subsequent modules for your topics. So every time you have a new module to do, you're just going to run this program get_module.sh. So we'll download the first module now by just running our program getmodule.sh. Enter. It's going to prompt you for credentials. The credentials are the same for your account on 22 Academia. So I'm just going to use, this is just a guest one. So once you put in the correct credentials, the get module program is going to download the current module that is available for you. so you don't have to worry about which module you're up to. It will just automatically download the correct one that you're up to. So the download is complete. If we list the files in our current directory, we should see the first module. Now the modules are going to be downloaded initially as zip files. So the first module is called module 0, and these modules are folders, but when you download them, they're going to be downloaded as zip files. The reason that they're zip files is it makes it easier to transport all the files at once, because a zip file just compresses all the files in a folder into a single file, so it makes it easier to transport all the data at once, as opposed to just sort of separately transferring the files in the entire folder one by one. The modules will be downloaded as zip files. So what you're going to have to do is you're going to type unzip module, unzip the module, enter. And then now I'm just going to clear this. Now if we list, we should see our actual folder for the module, which is module 0. We can go ahead after we've unzipped the zip file, we can go ahead and remove the zip file. Just remember, rm is a very destructive command, meaning that it's not the same. When you type rm followed by a file, it's not the same thing as just deleting a file using by just moving it to the bin. Because when you click move to the bin, the file is still on the computer. It's just relocated to the bin. But when you go rm, you're actually deleting the file. So just keep that in mind, that once you rm a file, you can't easily recover it. So we can go ahead and remove the zip file. I'm just gonna open up the current directory that we're in inside Finder. So we can use the open command followed by a dot. Dot represents the current directory that we're in. So a single dot represents our current location. A double dot represents like the parent directory. So if I go open dot, then we can open up our current directory inside a Finder. So this is our first module. We recommend just keeping all the modules inside the one, just so that you know where to access all your files, and that just keep it all sort of like located in the same place. So we'll just keep it located here, and every time you get the next module, just run ./get module.sh, and it will download the next one, which is module 1, then module 2, then module 3, and then you unzip those files to get your folder. So this is what the first module looks like. Each of these folders, directories, are their own task, essentially, and you're required to essentially complete, or at least attempt, each task. The task will always be different for each module, but these 3 files here will always be in every module. So you will have a file test_or.sh. So if we run test_or.sh, this is just a program that tests all our tasks. Oh, sorry. Let's check where we are. We're inside the parent directory, so we need to change into module 0. And then now we can list. So if we run test_or.sh, we'll see that for all of our tasks, we have not completed any of them. So there's a mark here at the bottom. So right now we have 0 out of 4. Now let's have a look at what tasks we need to do. To do that, we can open up the task.md file. .md is just it's basically like a text file. So we can open that one up. in, we're going to open it up in text editor. Your text editor is probably, the background is probably white for your one, but yeah. And also the colors in your terminal they're probably the default colors. I've changed mine a little bit just to make things look a little like clearer for the videos. So basically every time you start doing a module, what you're gonna want to do is open up the task file, and just have a read of what you have to do. You can either do it like that, or you can just go directly to um, the 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 module inside the website. So if you go, so for the first topic, every topic will have the module at the top here, so you can like follow it there as well. It's the same thing. So for our first task, there is a sense of order to the tasks. So the first one is hello world, the second one is new line, third one is my name, and the fourth one is Wesley. But you don't have to do them in order. You could do it whichever way you like. But I'm pretty sure they do get, like, the idea is that they do get like progressively well, at least they're supposed to get progressively more difficult or something like that. Anyway, so the first task is called hello world. It wants us to edit the file named helloworld.c inside the hello world directory. Make changes to the file so that the program prints the following to terminal when ran. Hello world exclamation mark. Just keep in mind that when it's saying print to the terminal, in this example, the terminal is everything that's between these backticks. So when we execute the program, hello world, we expect just to see this message. Let's learn to write our first program. We have to change into the hello world directory. So we'll go cd hello. I'll use tab to autocomplete and then enter. And then we're going to list. So in each directory for the task, essentially it will normally always look like this. There will be a file called, another program called task.sh. This program just tests the program that you make, so you can see whether or not what you made is correct. And then there's a sample program here. So we can run the sample program and see what the task wants us to do. So if we hit enter, then we get a response. This program sample prints hello world exclamation mark to the terminal. Task is saying to edit the file named hello world.c inside the hello world directory. So we're inside of the hello world directory, and hello world.c is here. So we're gonna open up hello world.c in a text editor and edit the file. So you can either do that using open-a. I'm actually not sure if this is the command, but hello underscore world. We'll see if that works. Okay, that does work. So you can either open up hello world.c like that if you want to use text edit as your text editor, or you could just go and find the file and just open it with text edit like that. Same thing. So I'm just going to put that here. Okay. So the right side here is going to be our hello world.c source file for our program, and the left side is just the file for tasks. So this is what we're doing at the moment. Every time we want to make a C program. This is the basic structure for a C program. So you're gonna always have to write hash include less than stdio.h greater than, and then you're gonna have to write int main, and then open bracket, close bracket, and then open curly brace, and then you have to write the closing curly brace, and in between that, this is called the main function. So in between the main function, at the end, you're going to write a return statement, so return 0, and then semicolon. So with hash include standard input output.h, this is just essentially another file that will give you access to some basic C commands and functions. And int main, this entire thing is called the main function, and essentially it serves as an entry point for your computer to start your program. So all the instructions that you want your program to run are going to be essentially inside the main function, in between the main function's curly brackets. So all your code is going to go here. So our task is to edit hello_world.c and make it so that it prints hello world to the terminal. So if we want to print messages to the terminal or print text to the terminal, we have to use a function, a C function, and that function is called printf. Now every time we use a function, you're gonna have to write this pattern where you use an open bracket, and then you have to close the bracket. And in between the brackets, we're gonna use double quotation marks. So like this, and the message that we want to print is gonna go in between the quotation marks. So we'll write hello world. And then in C, every time we write a statement, essentially you're gonna have to add a semicolon at the end of the statement. What this does is it tells the computer when an instruction ends. So you can think of it like a full stop, essentially. An important thing to understand about programs is that programs are executed more or less line by line. So when this program starts, so what we have here is the source code for our program, meaning the human readable code for our program. So when our program starts, what it's going to do is it's going to essentially go onto the first line. The computer is going to read the first line, and it's going to see that there's nothing there. There's no instructions there. Then it's going to go to the next line, and then see that there's nothing there. And then it's going to read on line number 3, it's going to read the hash include standard input output.h. And then it's going to go to the next line, and then the next line, and then so on and so forth. So programs are executed. There's a sense of order in a program. Things are executed sequentially. You don't have to worry too much about the white space. So like meaning like, you know, if I add a few spaces here, or like a few spaces there, or even if I add like a few lines here, it doesn't matter. The computer will essentially just ignore that, because we're using the semicolon, because it uses the semicolons to recognize when an instruction ends. So really, we could actually write the program like this as well. This is also like a valid way of writing the program. It's the same thing. We could write the program like that. But the reason why we don't write programs like this is because it's very hard to read what's going on. So that's why when we write programs, we want to format it a little nicely so that it's easier for ourselves to read later on or for other people to read. So usually I like to add a few spaces in between I like to make our program sort of look like this. So I'll add like a space, a line here and a line there. Okay, let's save our source file. So I'm just gonna, you can go Command S, or you can just like go and save it here. Now, in order to execute the program that we've written, what we're gonna have to do is we're gonna have to translate our text, our human readable code, into machine code. So right now what we have here is referred to as source code, which means it's human readable code. Now, a computer doesn't understand text. Like, it doesn't know what printf is or any of this stuff is. A computer only understands binary, essentially, or machine code. So we're going to have to translate our source code into machine code. And the way we're going to do this is by using another program called a compiler. So a compiler is going to take our source code and translate it into machine code. More specifically, we're going to use a C compiler named clang. So if we go back to the terminal, you just want to make sure that we have clang installed. You can type clang -- version to check if you have clang installed. Now, if you do have it installed, the terminal should respond with something like this. It should say like what the version is and like where it's at, that sort of stuff. If this sort of message doesn't come up and it says something else, it means that you probably don't have it installed. So you can check this video out to see how to install Clang. It should be pretty easy to install. Like, it should come installed on Macs by default, or at least some sort of version of it should. Okay, so we've saved our source file. Now, to convert our source code into machine code, this process is called compilation, either compilation or compiling. But basically, we need to compile our source code into machine code. So the command is going to be clang, because we're using the program clang to do it. And we're going to give it the name of our source file, hello-world.c, and then we're going to write -o, and now we're going to give it a name to call our executable file. An executable file is just a file that contains the machine code. So basically, Clang takes the source code and it makes a new file that contains machine code. So we'll still have our original source file, which is hello-world.c, but we'll just have another file now called an executable file. It's pretty standard practice to just name the executable file the same thing as the source file, but without the .c. Just gonna hit enter. Okay, so there's an error. Now, if there's an error with compiling our source file, the program clang will tell us what the error is. Now, clearly the error that it's saying is we have some invalid C, which is this line here. I just sort of added here as a note. So I'm going to remove that and then save our hello world.c file again and then run our command to compile again. Okay, so if clang doesn't respond with any errors, that means compilation was successful. And if we list, we should see our executable file hello world here. You might have noticed that all the files that are in red are executable files, meaning that they're programs that can be executed. So let's run our hello world that we just made. See, we've got a message saying hello world. Now, I've made a mistake in our program. If I run this sample, you can see that when we ran our hello world, the one that we just made, that the terminal didn't return on a new line. It returned on the same line that our message printed out. And also I'm missing an exclamation mark. So we can compare the program that we made with the sample to see whether what we wrote looks correct, or we can also just run our test.sh. Test.sh will take the executable that we produced and it will compare it essentially with the sample for us and it will tell us if it's correct. So you can see here that we've failed. It's saying that we test.sh received hello world, and then these three dots here just mean end of the file. So it's expected that we should get hello world and then a new line, but instead we got the new line on the same line as the hello world, and we're also missing the exclamation mark. So we can fix that pretty easily. We'll just add the exclamation mark here, and to add new lines inside the double quotes, you're going to use a backslash and then an N, which means new line. So backslash N equals to new line. So let's just save this our source file again. I'm going to clear. Now every time we make an edit to the source file, we have to, in order for that to be reflected in our program, we have to recompile our executable file because we made an edit to the source file, but the executable file is not changed. The executable file still represents the previous source file. So just keep in mind that every time we make changes to our source file, that we have to recompile our executable. When we run the command clang hello world.c-o hello world, when we run that again, the new executable file is going to replace the old version, the old executable file. So it's not going to make another copy of the executable unless you name the executable something else, like then it will make another copy. So you'll see here that we have the second version here. Okay, if we run hello world, our new version, So we've got our exclamation mark, and we've got it on and the prompt returns on a new line. So if we run task.sh, we've passed this test, and congratulations, that's our first C program that we've written. You are now a programmer. Woohoo! If we go back out to the parent directory, our module 0 directory, if we run test_all.sh now, we should see that we've passed our first task, and now we have to do the next one, which is new line. So right now we've got a mark of 1 out of 4. So let's go back to our task.md file and scroll down to our next task, newline.c. Navigate to the new line directory, create a file named newline.c, and write a program that prints the following to terminal. Okay, so it wants us to print basically this. So that's one space, two space. That's a new line character here, and another new line character, and another new line character, and then a W, followed by another new line character, and then an 8 with another new line character, and I think another new line character. Alright, so let's navigate to the new line directory. Let's go cd new line, enter. That's ls. So this time we're gonna have to make our source file. So before, if we go back to hello world, before our source file was given to us, and we just had to make an edit to the hello world.c source file. This time we have to make our source file. So we're going to use the touch command to make a file called newline.c, enter. If we list, we can see that now we have our source file here. We can get rid of our hello world.c. Let's open up our directory inside Finder. So open space dot, enter. And we've got our source file here. I'm going to open that up in text edit. We should expect that our source file is empty. Alright, so let's write the basic structure that we're always going to have to write in order to have a valid C program. It's going to be hash include less than stdio.h greater than. And then we're going to have our main function, int main. The int stands for integer. We'll talk more about that a little later. So int main, open bracket, closing bracket, open curly brace, and then we'll add some spaces and add a closing curly brace. And then we'll have a return 0 so that the computer knows that that's the end of our program. I think I might switch these around. Now that we have our basic C program, let's start printing our characters to the terminal. So again, we're going to use our printf function that we have available to us from the hash include standard input output library. So printf open quote end quote close bracket and a semicolon to end that off. Now, just to confirm what we want to print in the terminal, let's go back to our new line directory and run our sample ./sample. So if I highlight the output here, that should be a new line. What's one new line? Another new line, and then another new line. And then, so it will be like, this is a new line here, that's a new line there, this is a new line, and then we're going to have a W with another new line, because that takes us to the 8, and then an 8 and another new line. So the string should look something like this if we were to write it all in one line in printf. I'm just going to copy that. So in between our double quotes, let's just put that there. We could do it like this, or we could also do it like we can have that single new line and then another one, and then we can have another one. You know what, let's just try it like this. So new line, new line, new line, W, and then another new line, and then another one, this time in 8, and another new line, and then close bracket, semicolon. Alright, let's save our source file and go back to terminal. Alright, so the command to compile our source file and produce an executable file is clang source file -output executable file. So replace the source file with our new line.c, and then we can replace our executable file with a name that we want to call our executable -o. Then we'll call our we can name our executable file anything that we'd like. So maybe this time we'll name it my program. See, clang says that there's an error. There's actually more words here, but it blends with the background, so it's a bit hard to see. So that's my fault. But yeah, so we've misspelled a printf somewhere. So we've misspelled the last printf here. So clang's pretty useful. It's pretty smart. It'll tell us if essentially if what we've written in our program is not valid at C, then clang will tell us if if it's not valid and it's wrong. So let's save our file again and go back and run our command again. So no response was given, which means that if we clear and list, we have our program right here. So if we run my program, now just from looking at this and comparing it to sample, I can already see that we're missing a new line here, which I guess that makes sense because if we didn't have another new line there, then this would just be up here as opposed to having that additional line here. So we can go ahead and on the last one, add a new line here, and then save our source file again, and recompile our source file. Clang new line.c -o, and then my program. Let's run my program. Let's run my program. That looks basically the same. We could test it out with test.sh. Now, if we run test.sh, it's going to say new line executable does not exist. This is because we named our executable file my program. So test.sh what it will do is, if you don't give it the name of a file, it will automatically try and look for an executable that's the same name as the task. So if you name your executable something different, like my program, in order to test it, you have to give it test.sh the name of your executable. Sorry. And there we go. We've passed our second task, new line. So if we go back out to the parent directory and we run test_all.sh, we can see that we've passed our first two, and the next one is my name. So let's change into my name and we'll get ready for that. Okay, back into task. I scroll down. So navigate to the my name directory, create a file and write a program that prints your name in this sentence. Hi, my name is Wesley. So replace Wesley with your name. So basically whatever your name is, if let's say your name is Gary, then we can replace that with your name Gary, and it should be correct regardless of what name you put there. So let's try it out. Let's navigate to the my name directory. So we're already here. Let's make our source file. I'm gonna touch my name.c. If we ls, we can see that our source file my name.c is there. Let's open it up. Just gonna get rid of new line. Open up your file with text edit. Just use text edit for now. We're gonna use a different text editor later on in the course, but for now, we'll just use text edit. Okay, we're gonna write this one a little quicker this time. So the basic structure of a C program is hash include stdio.h, then int main, open bracket, close bracket, because main is a function and all functions have this open bracket, close bracket, and open curly brace, close curly brace sort of pattern. And then our code is going to go in between the curly braces. Let's add our return statement to end the program. And we're going to put our code here. So we're going to write a message to the terminal using a printf function. End it. Hi, my name is. Now, my name's Wesley, so I'm just going to put that there. And then if we have a look here, basically you generally always want to add a new line when you're printing things, or else the terminal will it will just look funny if the terminal goes back to the same line, the prompt goes back to the same line. So that should be it. That's our program. Hi, my name is Wesley. So yeah, replace Wesley with whatever your name is. Maybe we'll just go Gary here. Save. Back to terminal. Let's compile our myname.c source file. So it's going to be clang myname.c -o, and then we'll just call out executable myname. If we list, we can see our executable here. Let's run my name. My name is Gary. I'm just gonna skip the sample and we'll go straight to test. And ta-da, we've passed our third task, my name. By the way, in all of the tasks for the first module, there's another file called help.md. Basically, it's just has, I don't know, more detailed instructions. If you get stuck, then yeah, maybe have a read of this. Okay, so let's go back out to the parent directory. I'm just going to clear the screen. You may have noticed that I tend to clear the screen quite often. I just find it annoying when the terminal gets very messy, so it's like when there's a lot of things to see. So that's why I clear the screen. Okay, I'm just going to run test_all. So we've done our first 3 modules. Now, the next one is Wesley. So, navigate to the Wesley directory, create a file, and write a program that prints Wesley in the following pattern. So it wants us to print Wesley like a triangle sort of diagonal pattern. So basically, we can sort of run through the logic here. So the first character that we're printing is going to be a W, and then we're going to immediately go into a new line. So there's going to be like a new line here, and then the cursor is going to go here on the new line, but the E is 1 space over. So there's going to be like a space character before we go to the E, but then after the E, it wants us to go to another new line. So then there's going to be a new line here. And then on this line here, on the S1, there's going to be 2 spaces. Before we get to the S, and then another new line here to go to the L line. So that's the pattern. Let's change into Wesley. Okay, we're going to use touch to make a new file. Let's open up the current directory in Finder. Then open up our source file in TextEdit. Alright, let's make the basic structure of our C program. So hash include tdio.h, don't forget the greater than and less than signs. I'm pretty sure we can like do it. Nah, I think we can do it like this. I mean, I think that's valid. I'm not too sure. But generally, I want to encourage you, when you're not sure about whether or not something works or is valid C, all you have to do is just save the source file, just make the program and compile the program. And if it's not valid, then clang will tell you. So since our program did compile, if we run Wesley, then yeah, we had a valid program. It's just our program did nothing. So this sort of syntax is valid. When you hear the word syntax, it just refers to the pattern of a language that because all different programming languages have their own sort of patterns in the sense of like how they write things. So syntax just refers to sort of the structure or the way things are written. So let's go back and finish off the last task. So we want Wesley in this pattern. So the first letter is W. Oh, and then we have a new line. We'll end that off. And then close the function. So that's our first line. Now for our second line, where our cursor is going to start here, so we have to go one space over before we have an E, and then on to the next line. Just remember, everything that's in between the double quotes is going to be printed. So, you know, if you put a tab there, then it's going to print the tab. And also, with printf, you have to use double quotes. I'm pretty sure you can't use single quotes. But yeah, I mean, just check if you're not sure. Okay, so on the line with S, you know, we can just follow the pattern. So E is one space. This must be two spaces. So then the next one must be three spaces. 1, 2, 3. 1, 2, 3. L. And then new line. We can also just let's write the next two lines in the same printf. So since we're on a new line now, this E here should be four spaces before we get to the E. So let's do 1, 2, 3, 4, then E, and then a new line, and then Y should be 5 spaces. 1, 2, 3, 4, 5, Y, and then our new line. So I think this should work. If we just save this, and then go back to terminal, and recompile our, remember we have to recompile our source file, because if I just run Wesley right now, the current machine code inside Wesley was nothing before when we had this. Okay, let's run Wesley, and there we go. That looks about right. If we run sample, looks like the same thing. Let's see if it is. And yes, it is. Very nice. Okay, let's go back out to the module and run test_all.sh, enter. And there we go. We've completed our module. Woohoo! You've completed your first module. Great job, you're a programmer now. Congratulations, guys. You've completed your first module. Now, what we have to do from here is you have to submit your module after you complete it. So it doesn't automatically submit, you have to submit it yourself. So if we list, we're going to use this program here, submit.sh. So just run submit.sh, enter. You're going to have to give it your credentials. So I'm using the guest account. Just put your credentials for your account. And basically, this program submit.sh is just going to send your marks and your module results to our computers, our servers. And there you go. Submission received. At this time, good work. Every topic has its own module. In order to progress to the next topic, you have to complete the current topic's module. The reason why we're doing it like this is because a lot of the information in subsequent topics build on top of previous information. So we want to just make sure that you guys have sort of a sufficient level of understanding before you continue through the course, because it can get quite difficult if you don't understand some fundamentals from previous topics. So that's why we do it like that. You don't have to get 100% in all your modules. You just have to get above 70%. So you can see in your mark that there'll be a percentage that you could see, but yeah, you just have to get above 70% in your modules in order to continue on to your next topic. So that's it for this video. In this video, we covered how to write basic C programs, and we talked about the basic structure of a C program and how programs are executed sequentially, or how instructions in programs are executed line by line. We also talked about how to convert our C source code into machine code, and machine code is code that a computer understands and can execute.